All right, let's take a look at just a couple more examples here of basic probabilities that really just involve counting techniques. An urn contains 22 marbles. An urn contains 22 marbles. There are 10 that are red, 5 that are green, and 7 that are orange. You pick 2 at random. 2 at random without replacement. Without replacement. Without replacement. If you're wondering what an urn is, think of it as like a big jar, maybe, or like a vase or vase. 2 at random. So maybe you say you can't see in it, so you reach your hand into this giant vase, and you're gonna grab 2 balls. We'll grab 1 at a time here. Without replacement. What is the probability? What is the probability? Let's say we grab 1 at a time. What is the probability that the first is red? First is red, and the second is orange. What is the probability that the first is red and the second is orange? Well, this is just a multiplication rule problem. What is the very clearly 2 stages, right? Stage 1, maybe this just might as well color code this, right? Step 1 or stage 1, draw a red ball. Draw a red. Well, there are 22 marbles. 10 of them are red, so there's a 10 in 22 shot of getting a red ball. Okay. Now, you do this without replacement. So in stage 2, you got to be careful here. There is 1 less marble there. There is 1 less marble because you've taken 1 red one out already. So now we want to draw an orange. Draw an orange. There are only... Draw an orange one. There's only 21 left because this is done without replacement. How many are orange? There's still 7 orange in there, right? Because the first one you drew was red, so you're not reducing the pool of orange marbles you have. So the second stage, you have 7 over 21. So, in conclusion, via multiplication rule then, the desired probability would be 10 over 22 times 7 over 21. And that is 70 on the numerator. 22 times 21. Check a calculator there. That's 462. So 70 over 462, which is approximately 0.1515, or 15.15%. There we go. Let's do one more example here in this video. 4 married couples have bought 8 seats in the same row. 4 married couples have bought 8 seats in the same row for a show. For a show. Let A be the event that each couple sits together. A is the event that each couple sits together. Find the probability of A. Find the probability of A. All right. 4 married couples have bought 8 seats in the same row for a show. A is the event that each couple sits together. Let's find the probability that each couple sits together. The idea here is that any seating arrangement is equally likely. Like they sit down at random, or you think about buying your tickets, right? You buy 8 tickets. Each person just gets 1 ticket. What are the odds that each couple gets to sit together? All right. Well, let's take a look here. First, let's think about our whole sample space. How many ways are there for the 8 couples, or for the 8 people to sit in that row? How many ways are there for the 8 people to sit in the row? Well, total number of ways to seat 8 people. Total number of ways to seat 8 people. Think about this. In the first seat, how many options do you have at that? If you think about each seat as a stage, in the first seat, or each seat as a step, there are 8 people that could sit in that first seat. Now, once someone is sitting down in that first seat, there are only 7 people available to sit in the second, right? And then in the next seat, there are only 6, so on and so forth. This is just 8 factorial. Total number of ways to see 8 people in a line. 8 factorial different ways to do that. 8 factorial, run that through a calculator, is 4,320. I'm not going to put a box on that. I'll underline it because I'm going to need that later. So there's my total sample space, 40,320. So now the question is, how many ways... How many ways can each couple sit together? How many ways can each couple sit together? How many ways can each couple sit together? All right. Now, there are a variety of ways that you can think about this specific instance. All right. I'll try to arrive at this number in 2 ways. So you can see that, maybe take your preference. It's also nice to be aware of both solutions, because if this question gets asked again, but in a slightly different fashion, one strategy might lend itself better than the other one. So here's the first way I would go about thinking about this. Let me just see here. If the couples are going to sit together, then I can focus on the couple as an entity itself. So rather than being 8 separate people, there's just 4 different couples. And so I would say, well, how many ways are there to seat 4 couples? Well, there would be 4 factorial ways to seat the 4 couples. 4 factorial ways to seat the 4 couples. Right? 4 factorial, because you basically say you can have couple A go first, couple B second, couple C third, and couple D fourth, or any permutation of those 4. Now, for each of those ways, look at the individual couple itself, right? So for each of those arrangements, each couple can be arranged in 2 ways, right? You could have, in the couple, if you have, if they're, husband and wife or whatever, it could be husband-wife or wife-husband, right? Person 1, person 1 and person 2, or person 2 and person 1. So for each of these, each couple can be arranged in 2 ways. So we have 2 options for the first couple to be set, right? Left seat or right seat. 2 options for the second couple. 2 options for the third, and 2 options for the fourth. There are 16 different arrangements once the couple locations have been decided. Once the couple locations have been decided. struggling with my pen here. Oh, what is happening? It just got thicker. Have been decided. Let's reset that. So what do we have then? 4 factorial times 16. So that's 4 times 3 is 12. 12 times 2 is 24. So then we're looking at 24 times 16 then. So we have 24. So we have 4 factorial times 16 by the multiplication rule. And we run that through a calculator. That should be 384 ways. Okay. Alternatively, how else can you count this? How many ways can each couple sit together? Here's another way you can think about this, right? Much like we thought about the way we sat the 8 people originally, you think about the first seat. There are 8 people that can go in that first seat. But once you have that first person sat down, there is only one person that can go in the second seat because the couples are supposed to be sitting together. So let's just say, we're going to have 1, 2, 3, 4, 5, 6, 7, 8 seats, right? So you've got 8 options for someone in that first seat. Now in the second seat, you have 6 options for someone to go there, but once that is picked, there's only one option because, again, they have to be couples. That's a couple. That's a couple. 4 options here. 2 options here. There we go. And so we have 8 times 6 times 4 times 2. Let's see here. Notice the equivalent here because 8 times 2 is 16. And 6 times 4 is 24, which is 4 factorial. That is also equal to 384. So either way you want to think about it is just fine. But at the end of the day, the probability then, the desired probability, is going to be 384 over 40,320. The probability then, 384 over 40,320. 40,320. There we go.